Rosenberg, the CEO and Chief Scientist of Unanimous AI. And today I'm going to talk about collective superintelligence, using AI to amplify group intelligence to superhuman levels. And by group intelligence, I mean connecting large groups in real time to enable them to think together and amplify their intelligence. And by large groups, I mean groups of 50 people, 250 people, 2,500 people, potentially even 2 million people thinking together in real time, connected by AI to amplify their intelligence to levels that they just could never achieve on their own. Why collective superintelligence? I've been working in this field for over a decade, and it's based on a really controversial concept in the world of AI, namely that people are smart. People have vast amounts of knowledge, wisdom, insight, experience, intuition. And the big question that's really motivated me is how can we use AI to harness and amplify the intelligence of very large teams to drive smarter decisions, to solve harder problems, to produce better forecasts, to surface better ideas, to generate deeper insights, and to keep humans in the loop, especially in the loop of decision making. So the standard approach to collective intelligence is to collect data from individuals, knowledge, wisdom, insight by conducting polls, surveys, doing data scraping, watching people on the internet, collecting that data, putting it into a digital database, and then doing AI on it. And it turns out, when you follow this approach, you get pretty weak group intelligence. And it's not the AI that's weak, it's the data. And the reason is that humans are not just data points for statistical aggregation. Humans are data processors who can evaluate, deliberate, reflect, and we need to treat people like data processors, because if we don't, when you replace real people with the data collected from people, you lose most of their collective intelligence. And so the radical idea that's motivated my work and the work at Unanimous AI over the last decade is to treat people like people. And this translates into treating teams like teams. So if you want to really amplify intelligence, we can look at how do teams best amplify intelligence. And it turns out that group deliberation is the most effective method for amplifying the intelligence of teams. And we all inherently know this, right? We know that real-time conversation among teams enables them to combine their knowledge, their wisdom, their insights, and to solve problems together, to brainstorm ideas together, building on the ideas of others, to debate opinions, batting things back and forth, and to converge on optimal solutions. But there's a big problem. And the problem is conversations only work in small groups. Decades of research have shown that the optimal size for a group deliberation is really only 4 to 7 people. Each person gets a good amount of airtime to speak, a small amount of wait time to respond to others, but as you increase a group size, airtime drops, wait time increases, and when you get to about 8 to 10 people, it really just becomes a series of speeches, and above 20 people, it's just chaos. So what do you do if you have a large team, like a Fortune 1000 company? Average size of a Fortune 1000 company, over 30,000 employees. Product teams have hundreds of members, sales teams have hundreds of members, support teams have hundreds of members. Can you bring those people into a Zoom call? Can you bring 50 people in, 100 people into a Zoom call? No, you can't even bring 20 people in and have a deliberation. And so the big question is really, today's teams cannot have productive deliberations of really more than 8 to 10 people. And that's a crazy problem. And the big question is, well, how can we possibly solve it? And what we did, like a lot of researchers do, is we actually looked to Mother Nature for guidance. Turns out that Mother Nature has been looking into this problem for a few 100 million years. And it's called swarm intelligence. Swarm intelligence is nature's method for amplifying the intelligence of large groups. Now, what nature does not do, nature does not take votes or polls or surveys. There's no survey monkey in nature. What nature does is it forms systems, real-time systems with feedback loops that enable groups to converge. Now, when I say deliberate, when a large group deliberates with feedback loops, I really mean in the form of a natural system, having this real-time tug of war among participants. They pull and push on each other in real time, find the solution that maximizes their collective conviction, and it significantly amplifies their intelligence. This is a reason why birds flock and fish school and bees swarm. They are smarter together than alone. So let's look at an example of a remarkable example of decision-making in the natural world, fish schools. So fish schools are nature's optimized organization. Looks like we have some weird slide. So fish schools are nature's optimized organization. If you think about a fish school, you have a remarkable collection of thousands of individuals. Nobody's in charge, and yet they can make all of life's decisions, finding their way through the oceans, dealing with predators, finding food, seamlessly and efficiently. In fact, biologists refer to fish schools as a superorganism because they function so efficiently together. How do they do this? How do fish schools connect together so well? Well, they actually have a special organ on the side of their bodies called a lateral line. And it detects pressure and vibration in the water around them. And that allows them to detect the intentions of all their neighbors. And so these small groups of fish can have a little tug of war to make a decision, and the magic happens is because all of these groups of neighbors overlap, and the information propagates through the full school. So they can make these fast, amazing, rapid decisions. So let's look at an actual decision. So here's a fish school. Let's give them a problem to solve. 3 predators that are coming from 3 different directions. Now, this is a really interesting problem because no individual has enough information to solve this problem. And all individuals have limited information. And so if you look at this fish school, it's just like a real human organization. There might be pockets of teams inside of this large organization that's aware of different problems, but nobody has enough information to solve the whole thing. So in this situation, there's a fish school, there's a small group in the upper left. They see a predator coming. They have their little tug of war, and they move down into the right. There's a group in the lower left. They see a predator coming. They have their tug of war, and they decide, oh, we're going to move up into the right. And there's a school in a little group in the upper right. They have their deliberation. They're going to move down into the left. Now, these are 3 different teams making decisions. It's not a collective intelligence. It's not a collective superintelligence. The magic happens because these groups overlap, and the information can propagate through the full school really quickly, and it results in an optimal decision that's fast and effective. And so the big question that hit our team at Unanimous AI years and years ago is, if this works for birds and bees and fish, can it work for human groups, and can it work conversationally? And so let's say I have a large group of 200 people. I want this group to deliberate. I cannot have them have a conversation in any natural environment. So Mother Nature would say the thing to do is first break this group of 200 people up into small groups. So boom, we can turn them into 40 groups of 5. Great. Then what Mother Nature says is these groups need to overlap. Well, we can do that too. The problem is this fails. this fails because we humans are not fish, and we cannot be in multiple conversations at once. And in fact, there's a name for it. It's called the cocktail party problem. If you're in a cocktail party and you're talking to a small group, and then there's another group right next to you, and you shift your attention to that other group because they're saying something more interesting, you lose your focus on the group you're in. So this fails, and this is why this has been an unsolved problem in communication and collaboration and collective intelligence for 100 years. We cannot allow these groups to overlap, but we solved this. And we solved this with the creation of a unique artificial agent that we call a conversational surrogate agent. And we make this agent, and we put one of these agents into every one of these different groups. And then we give this agent a very specific task. They participate in this small group of, say, 5 people. Their job is to observe that group, to extract key insights out of that group in real time. They're watching the conversation in real time. They're watching every individual. They're extracting key ideas. They're extracting reasons that support those ideas. They're extracting counterpoints that oppose those ideas. And then they're passing that information to the agents in other groups. And the agents in those other groups express those ideas conversationally in those groups. And this weaves all of the conversations together into a single unified dialogue where 200 people, 500 people, 1 million people could brainstorm together, debate together, prioritize together, forecast together, and converge on solutions that optimize and maximize their collective confidence and conviction. And so we call this technology HyperChat AI technology. And it enables thoughtful, real-time conversation at potentially any scale. And just to give you a sense, when you're in one of these rooms, you're talking to 4 or 5 other people. There's an AI agent that's participating. That AI is not making things up. It's not grabbing things off the internet. It's expressing human insights that were passed to it from other groups in an optimal way. And so what happens here is we have this HyperChat AI technology. AI agents are passing information around the network, and it turns out that it optimizes collaboration and it amplifies team intelligence. And the reason it does this is that unlike a fish school, where information has to propagate through the school based on proximity, in HyperChat, information can pass between any groups in the network at any time, and it uses an AI system that's actually working to maximize the mixing of ideas and opinions and reasoning. And so if one group is brainstorming on one topic, there's no reason to pass something similar into that group. In fact, the best thing to do is to pass something very different. Because when groups challenge each other, the information that comes in drives behavior out of the group that received it. If everybody agrees, you learn almost nothing about those groups. If everybody's consistently being challenged, we learn whether those ideas sway those groups or whether those groups push back, and we learn the counterpoints, and those get passed around the network. And so this is HyperChat AI. Last year, we built this into a platform called ThinkScape, where we can bring up to 250 people in real time to brainstorm, deliberate, prioritize, forecast, and converge. It's currently text chat or voice to text. People can speak just voice and it goes in. And in Q4, we're launching the next version, which is video conferencing. So 250 people in a single real-time video conference that's networked together, and everybody's connected and can, again, brainstorm, prioritize, deliberate, and solve problems. So the question is, well, does this make groups smarter? So we've been partnering with lots of universities, Stanford, Harvard, Carnegie Mellon, MIT, to run tests and demonstrate, does this actually make groups smarter like it does in nature? And so I'll talk about just 2. We ran a study with Carnegie Mellon University that we published last year, where we gave IQ tests to groups of 35 people. So This is called a Raven's Matrix IQ test. It's completely visual. It's complete the pattern IQ test. And so we ran lots of groups of 35, and then we looked at 3 different cases. We looked at the average individual, the wisdom of crowd, and using ThinkScape, HyperChat AI. And so the average individual in each group of 35 scored 100 IQ, which is the 50th percentile, and that's how IQ tests are designed. The wisdom of crowd, which is standard collective intelligence, looks at the most popular answer across groups of 35. And wisdom of crowd works, standard collective intelligence works. It boosted the IQ to 115, which is the 81st percentile. But even if we went to bigger groups, it could never get beyond that. And then we looked at ThinkScape with groups, again, groups of 35, and we saw that when the groups were connected this way, their IQ boosted to 128. They were the 97th percentile, which is a gifted level intelligence. And even more important, these groups consistently outperformed every member of the group. So in the world of collective intelligence, people are usually excited when their result outperforms the median individual. But here we outperformed every member, and that's really where we're getting to this idea of collective superintelligence, where we can enable systems where the humans can outperform consistently every participant. And this is a published study. You can see it on our website at Unanimous.ai. And then we did another study, which was published this year, brainstorming study. So we had large groups of 75 people brainstorm together in real time. And we used what's called an alternative use task, which is a standard brainstorming intervention. And what happens in an alternative use task is you give people a common object, like a plunger or really anything. And you say, you've got a warehouse full of these objects. You can't sell them as plungers. Come up with ideas of how you're going to get rid of these plungers and then prioritize them to find the best ideas. And so we did that with groups of 75, either as a single big group in a standard framework like Slack or Teams or Discord, or in ThinkScape, connected together by these HyperChat technology. And what we found was that people greatly, dramatically preferred deliberating in these interconnected network groups connected by AI. What we found in the published study was that, first of all, people found the process of brainstorming this way to be significantly more productive. They also all reported, at 88% of people reported they felt more heard, which is so fascinating, because if you're in a single big group of 75 and you say something, in theory, everybody heard you. But when you're in these small groups and AI agents are passing information around the network, you feel more heard. They said they felt more collaborative. They said it surfaced better answers. They felt more buy-in to the result. They felt more ownership, and they preferred it overall. And again, this is a published study with Carnegie Mellon that you can find on our website at unanimous.ai. So this is ThinkScape, the current version. Groups of up to 250 people can log in from anywhere in the world. All they need is an invite, and they come in just like going into a Zoom meeting. They come to a world that looks like this. In this case, you can see the list of participants. There's 110 people who are going to deliberate. That could have been 250, and next year we'll be able to go up to 1,000 in a single deliberation. There's a conversation visualizer that allows every person to have the mental model of what's happening. So they can see there are 110 people, but they've been broken up into 22 different think tanks. And they know which think tank they're in, because we want them to understand exactly what's happening. There's an area where they can chat. There's an area where they can do voice to text. And there's an area where they can share videos or images or any type of content. And then the team leader or a moderator can ask a question to the group. And so in this case, the question is, what is the biggest concern about building nuclear power plants in the United States, and why? And this was actually done by the Department of Energy, and the participants in this case were 110 members of the public. And so then the discussion starts, and the group's going to deliberate. They all see the question. They're all told to support their positions with reasons, because this is all about debating and deliberating with reasons. And they're told, if you disagree with somebody, tell them, because we want them to disagree. And then in this case, it's 6 minutes, and they start deliberating. And so this is 110 people deliberating. This looks like chaos. Nobody would watch the conversation this way because it's the moderator view. This is the bird's eye view of the conversation. But you can see that all the people can see the AI agents passing information around the network, so they know what's happening. The moderator can click on any one of these think tanks while they're watching this happen and just jump into that think tank. And then and this is what it looks like in think tank 11. And so now it's a very controlled conversation, 4 or 5 people having a discussion, an AI participating in that discussion. I'll zoom in on what an AI says because I know it's small. And so here, ThinkBot Eve says, well, what about the financial risk and cost overruns of building nuclear power plants? And so it's bringing this notion into the group because it hasn't come up organically and they haven't been exposed to this before. And it tells the group, oh, this is from Think Tank 4. It's not that the people in Think Tank 11 care that it came from Think Tank 4. It's that the AI agent is reminding them, hey, I did not make this up. I am passing human intelligence to you, and you should judge it like you would any human intelligence. You can also click for real-time insights. And so if you are the team leader or the moderator, you can watch the entire conversation from a bird's eye view in a really convenient form. So here's 110 people deliberating. You can see in real time, it's showing you all the ideas that come up, and it's tracking the sentiment across the whole network for all those ideas. It's giving you other metrics about the ideas that come up. You can also look and see all the reasons that are in favor of every idea, all the reasons against every idea as they come up. It's showing you key verbatims from all the different, across the whole network that would allow you as the moderator just to follow the general feel of what's happening during this conversation. And then it's also showing you how the conversation's unfolding. And you can see all of these think tanks are color-coded, and those colors correspond to the different ideas. And so you can see, like if you do a brainstorm, it'll start out with all different colors, but over time, as the group deliberates, as they find their consensus, all those colors start to converge on similar colors, and then you're done. And then 6 minutes are up, and it instantly gives
Our collective perspective is that the biggest concern about building nuclear power plants in the United States is toxic waste. We consider the dangers of exposure to radioactive materials, its long-lasting environmental and health effects, and the challenges of safe storage and disposal. While some argued that waste is well contained and nuclear energy is more sustainable than ever, the majority felt the long-term risks outweighed these benefits.
So you get this result instantly at the end of a 110-person deliberation. Why do we present it? So that everybody knows this was the high-level collective consensus, so that the moderator or the team leader can then ask a follow-up question and can have a conversation of a person to 100 people or a person to 1 million people can have this real-time dialogue. And I'm out of time, so I will quickly wrap up. Next generation is video conferencing, really quick. Same exact thing, but now each group is a video conference, and the AI agent in each group is an animated avatar that's participating in the conversation, and our technology is weaving all the conversations together in real time. And so collective superintelligence, large human groups have weak collective intelligence, connect them together, we can turn them into a collective superintelligence that you can literally interview in real time and basically give a voice to 100 people, 1,000 people, and hopefully one day 1 million people.